Have you ever walked into a building, maybe your office, a hospital, even just the local coffee shop, and you just sort of exist in it, completely trusting it's safe? You probably don't give it a second thought. But behind every single door, every wall, every system, there's this incredible, often invisible amount of planning. Real intentional design focused on keeping you safe. It's like a silent guardian, working tirelessly in the background. Today we're doing a deep dive into that fascinating, really crucial world. Facility planning, design, and maintenance. We're going to pull back the curtain a bit, explore how safety and health aren't just tacked on later. They're meticulously woven into every single stage of a building's life, from the very start to the very end. Our sources, especially these comprehensive excerpts from facility planning, design, and maintenance, they make it really clear. Designing safety in from the start. It's not just smart, it's absolutely essential. It's the bedrock. So our mission for you today, if you're curious about this stuff, is to give you a shortcut. A way to understand the critical thinking, the meticulous processes that make the places we live, work, and play fundamentally secure and healthy. This isn't about, slapping on a Band-Aid after something goes wrong. It's about uncovering why being proactive about safety is always more effective, more robust, and, yeah, honestly, cheaper in the long run. You'll probably look at buildings a bit differently after this. So, okay, let's unpack this. The core idea here is that safety isn't something you bolt on at the end of a project, is it? It's baked in right from the very beginning, from the blueprint stage.
Absolutely. That's the key takeaway. And what's truly fascinating is that the planning and design phase isn't just important, it's identified as the most crucial part of the facility's entire life cycle.
Wow, the most crucial.
Yeah. Think about it. Decisions made right then about everything from picking the land to the materials you use, they have these huge long-term consequences for the safety, the health of the facility, and everyone who uses it for decades.
Right.
If you get the stage wrong, you're essentially building risk right into the foundation. It's much harder and more expensive to fix later.
Okay, so if the blueprint is where it all starts, what are some of those foundational decisions, the ones that have such a massive impact? What's actually happening even before, the first shovel hits the ground?
Well, we can break it down into a few key areas, things to consider long before construction kicks off. First up is site selection.
Okay.
And this isn't just, finding a nice spot on the map. It's a really deep dive. Planners are looking at critical safety stuff, like the land's topography and soil conditions for stability. Exactly. Is it stable? Are there geological hazards? Fault lines, sinkholes, unstable soil. Building on the wrong ground is just asking for trouble. We've seen disasters happen because of that. Beyond the ground itself, they assess proximity to resources.
Meaning?
Well, not just utilities, but access to emergency services, fire departments, hospitals. How quickly can help get there if something goes wrong?
Right. Response time.
Critical. A remote location adds inherent risk. Then you've got environmental factors.
Like weather?
Yeah. Is the area prone to floods, hurricanes, earthquakes? Even things like prevailing wind directions matter.
How so? Wind direction.
Well, for structural load, sure, but also for planning ventilation. How will smoke behave in a fire? Things like that.
Oh, wow.
And then, of course, there's security. Planning for physical security from day one. Things like controlled access points, maybe fencing, adequate lighting, all designed to deter threats and keep people safe as they move around.
That's a staggering amount of foresight needed. So many variables. But it's not just the physical side, right? There's a whole legal and standard side, too.
Oh, absolutely. A huge part of this initial phase is navigating codes and standards. This is where legal requirements and established best practices really form the backbone of a safe facility.
Right, the rule book.
Exactly. And compliance isn't optional. It's fundamental. We're talking about things like building codes. The International Building Code is a common one. These aren't just random rules. They set minimum standards for structural integrity, fire safety, electrical systems, occupancy limits, everything.
And they get updated, I imagine.
Constantly, often revised based on lessons learned from incidents. Then you have things like NFPA 101, the Life Safety Code.
Life safety code. Sounds important.
It is. It specifically focuses on protecting people from fire and other emergencies. It dictates requirements for egress, that means exits.
Getting out safely.
Precisely. Making sure there are enough exits, they're clearly marked, they're unobstructed. It also covers fire alarms, sprinkler systems, suppression systems. What's really insightful here is that these aren't just rules pulled out of thin air. They're often codified lessons from past tragedies.
So they're like a collective memory of danger built into the code.
That's a great way to put it. We proactively prevent what we've learned can happen.
Okay, and you mentioned OSHA standards earlier. How do those fit into the design phase? Isn't OSHA more about, like, workers on the job later?
It seems that way, but it's a critical connection. While OSHA standards mainly focus on operational safety, they deeply influence the design, because designers have to anticipate how people will work in and maintain the building.
Ah, okay. So thinking ahead to maintenance and operations.
Exactly. Things like ensuring enough clear space around machinery so it can be operated and maintained safely, making sure electrical panels are easily accessible but also safely located, specifying guardrails for elevated areas right in the plans.
So you don't have to retrofit later, which is expensive and maybe less effective.
Precisely. It prevents future hazards and costs, ensuring the building is safe not just for occupants, but for the maintenance crews too.
Got it. So site, codes, anticipating operations. What else is in this initial design phase?
Well, beyond just meeting the codes, there's what we call design for safety. This is about actively designing safety features into the facility, sometimes going beyond the bare minimum required by code.
Like what? What kind of features?
Think about the layout and arrangement of the space. It's not just about aesthetics or cramming things in. A good layout means clear paths for emergency responders,
Right.
unobstructed lines of sight for security, safe, intuitive traffic flow, especially in busy places like warehouses or hospitals, to prevent collisions. That impacts safety every single day.
Makes sense.
Then there's ensuring really good means of egress. We talked about exits, but it's the whole system. The number of exits, where they are, how wide corridors need to be, fire-rated doors.
You know, you see those really clear exit signs now, compared to older buildings maybe.
That clarity is a direct result of this kind of planning. No confusion in an emergency. Also, effective ventilation systems, designed from the start not just for comfort, but to control airborne contaminants. Good indoor air quality is a health and safety issue. And critically, ventilation helps manage smoke in a fire, keeping escape routes clearer.
Okay, air quality and smoke control. What else?
Lighting, planned strategically. Good lighting prevents trips and falls, reduces eye strain, and massively improves security by eliminating dark spots.
Simple, but effective.
Absolutely. And finally, accessibility. Complying with standards like the Americans with Disabilities Act, ADA, this is fundamental to making sure the facility is safe and usable for everyone, regardless of physical ability. Ramps, door widths, accessible restrooms, it's about universal safety.
Wow. It really isn't just a checklist, is it? It's this deep thinking, anticipating everything from a normal day to a worst-case scenario, and building the solutions right in from the start. You can see how these early choices echo through the building's entire life.
Exactly. The impact on every single person who uses that building is immense.
So that's a massive amount of planning, sets the stage. But even the best plan needs careful execution, right? Once the design's locked, construction begins. The focus on safety can't let up then, surely. Seems like a whole new set of risks pop up.
Not at all. You're absolutely right. The construction phase introduces its own unique, often significant hazards. It demands immediate, rigorous attention. And then, of course, the whole operational life of the facility needs constant vigilance.
Okay, so let's talk construction first. How do you manage safety there?
Well, first, there needs to be a comprehensive, site-specific construction safety plan. This isn't a generic template. It's tailored to that specific project's hazards working at heights. Excavation risks, heavy equipment, electrical work, whatever applies. It outlines procedures, who's responsible for what, emergency responses.
This is all of this plan, just the main builder.
That leads to the next crucial piece, contractor safety management. You need a rigorous process for selecting contractors. You look for ones with strong, proven safety records.
Vet them properly.
Exactly. Require them to submit their own detailed safety plans, and then you monitor them, ensure they stick to all the requirements throughout the job.
You get a one-week link.
Can jeopardize the whole project and, more importantly, the workers. You're only as safe as your least responsible partner on site. Cutting corners on safety during construction. The potential cost, human and financial, is just devastating.
Okay, so construction safety is managed tightly. Then the building's finished, people move in. What happens then? How does safety stay alive?
That's where maintenance and safety during the operational phase comes in. This is where safety becomes a living, breathing program. It's way more than just fixing leaky taps or broken lights.
That's proactive.
Absolutely. A huge part is preventive maintenance, or PM. This means scheduled inspections, adjustments, lubrication, replacing parts before they fail.
Like getting your car serviced regularly.
Exactly like that, but for the entire building systems. HVAC, electrical, fire suppression, elevators, emergency generators. A solid PM program is essential not just for safety, but it also extends equipment life and prevents costly breakdowns.
Makes sense. Is there anything beyond just scheduled checks?
Yes, there's also predictive maintenance. This uses technology sensors, data analysis, thermal imaging, vibration analysis to monitor equipment condition in real time. It aims to predict when maintenance will actually be needed.
So not just guessing based on time, but based on actual condition.
Right. It allows for really targeted intervention. You fix things just before they break, based on data. It avoids unnecessary work, minimizes downtime, and catches potential failures before they become safety hazards. It's smarter maintenance.
That's clever. And are there specific safety procedures for maintenance work itself? Some maintenance must be pretty risky.
Oh, definitely. There are highly critical safe maintenance procedures for specific high-risk tasks. A major one is lockout to gout, or LOTO.
Lockout to gout.
Yeah, it's vital for controlling hazardous energy, electrical, mechanical, hydraulic, whatever, when someone's working on equipment. It prevents the machinery from being accidentally turned on or releasing stored energy while someone's working on it.
Ah, so you physically lock the power source off.
Exactly. You lock it and tag it, saying who locked it and why. It prevents catastrophic accidents. Imagine someone turning on a machine while a colleague's inside repairing it. LOTO stops that.
Okay, crucial. What else?
Strict procedures for confined space entry. Entering places like tanks, silos, vaults, tunnels can be incredibly dangerous. Bad air quality, potential for engulfment. So there are rigorous protocols for testing the atmosphere, having rescue plans, attendance,
Right.
and things like hot work permits, required for any activity involving flames or sparks, welding, cutting, grinding. These permits ensure precautions are taken, like clearing combustibles, having fire watchers, extinguishers ready to minimize fire risk.
Each of those sounds like it came from learning the hard way.
Sadly, yes. Many of these procedures are written in lessons learned from past accidents. They exist to protect lives.
So putting it all together, safety isn't just about a strong initial build. It's about building in the right processes, fostering that culture of vigilance, and constantly maintaining everything. It's a continuous cycle, always adapting throughout the building's life.
That's it exactly, a continuous life cycle approach.
Incredible. Such an ongoing commitment. But okay, what about the very end? When a building's life is over, taking it down. That has to involve safety planning too, right? It can't just be a free-for-all with a wrecking ball.
Absolutely not. You're right. The facility life cycle concludes with demolition and disposal, and this stage has its own significant risks. It demands just as much careful management as the construction phase did.
So how do you approach safe demolition?
First, you need a detailed demolition plan. This isn't just about swinging the ball. It's an engineered strategy. It identifies hazards specific to that structure, plans for controlled collapse if necessary, manages dust and debris, plans for safe removal of materials.
Controlling how it comes down.
Precisely. But even before the major demolition starts, there's a critical, often complex step. Hazardous materials abatement.
Dealing with the nasty stuff left behind.
Exactly. Identifying and safely removing things like asbestos, lead paint, PCBs, mercury, things that were common building materials in the past.
Asbestos especially. That stuff is dangerous if disturbed.
Extremely. Disturbing it without proper controls releases fibers that cause serious long-term health issues. So, abatement protects the demolition workers, the nearby community, and the environment from exposure. It's a crucial health protection step.
Okay, get the hazards out first, then the demolition. What about the waste?
That's the final piece. Environmental compliance. You have to adhere to strict environmental regulations for disposing of all that demolition waste.
Can't just dump it anywhere.
No way. It involves sorting materials, metal for recycling, concrete for crushing maybe, and properly disposing of anything contaminated or non-recyclable. Preventing soil and water contamination is key. It ensures the site is left safe and clean, minimizing environmental impact.
It really is a full circle approach then. Responsibility right to the very end.
It truly is. From the first idea to the final bit of dust.
Wow. Okay, so what does this all mean for us, thinking about the buildings around us, this whole deep dive? It feels like it reveals this incredibly complex, critical framework. Planning, design, construction, operation, maintenance, even demolition. Safety clearly isn't an accident. It's meticulously engineered. It requires constant effort.
Yeah, and I think connecting it to the bigger picture. Understanding this integrated life cycle approach helps us appreciate something profound. The safety and well-being we often take for granted in the buildings we use, that's the result of constant deliberate effort across the entire lifespan.
Right. It's not magic, it's work.
It encourages you to think critically about those layers of protection, often invisible, that surround us almost everywhere. It gives you peace of mind, maybe, but also an appreciation for the process.
So maybe the next time you walk into any building or you see a new construction site or even hear about a demolition, perhaps you'll look at it a bit differently, not just as a structure, but as a kind of testament to all that intricate, proactive planning that goes into keeping us safe. It leaves you wondering, doesn't it? What hidden safety considerations might be at play in the spaces you use every day that you've never even thought about? And maybe more pointedly, what would it actually look like if even one of those layers of protection was missing? Makes you think.